Hey, Christian. So, right now I'm playing around with this this thing that I made called the shift router, and it's taking the idea out of the 4MS rotating clock divider and applying it to shifting between different oscillators. So I'll make a little example patch down here that shows, you can see visually what's going on. So 1, 2, 3, 4. I'm just really quickly double clicking on these and entering numbers and pressing enter really quickly. And then the meter. Let's see. Any plans for implementing MPE? Yes, and I did have a good fourth. Thank you, Stephen. Right now, there's this person on the forum. His name is Aftab. He goes by Afta8 on the forum, and he has been able to implement MPE for 4-note polyphony. So if you want to start a topic on the forum about MPE, that'd be great, and you know, get people talking about it. I don't currently really have an MPE controller. You know, saving up for one. Probably get one of the Livestream ones. Those seem really cool. But I know it's something that people are definitely asking for. So yeah. So back to this. So you got these numbers going in through here, and then the numbers coming out. And what this is doing is it's shifting the numbers down like that. And so you could use this to, if I could have, say, a math expression, and then you could say input divided by x, and then I'd have some input here, say like 1. Get another one of these, and attach that there, and then when I shift this, it will divide by those different numbers there. So divide by 2, divide by 5 is 0.2. And this is useful for, you know, doing different divide by clocks. But you can also, I realized you could do stuff where you could put, say, an oscillator into here. So I'll have different shapes here. just kind of randomly putting there. You might hear the little loud Yorkie dog downstairs. Okay. 34. What I'm doing is I'm highlighting these really quickly and pressing Command or Control C, Control V to copy paste. And you know what? I think I already have a neat little yes, like this thing. Bring that in here. I just opened up another file and just brought this kind of oscilloscope in. So you can see these are the different channels. It's kind of all chaotic. But what's fun is you can do stuff like, I can go here and take the saw wave and then change between them to different outputs. So I could have, you know, all sorts of different, you know, each one of these could be routed to a different filter, and you'd have the voice changing every time. If I take them all off and just go to 1 and increase the speed, you can see how it's drawing a unique waveform that's a combination of all of these different oscillators here. I can even have one that's at a different speed. Alright, and so that's creating an interesting LFO. You can see, get a knob here. And you see how there's no modulation kind of happening here on this knob. It's because it's not connected to anything. When a node like this isn't connected to anything, nothing's being processed on it because it's not going anywhere. But so you have to either connect it to an audio output or to a value node or a meter node like this, and then you'll see the modulation kick in. So I could use this as a modulation source, or I could, like I'm doing here, use it as an audio source. So if we just have the, if I skip over this part and just put the saw wave, that's just the saw wave sound, and it's got some pulse width modulation. It's more like a shape. And here's the square. And then what I've got here is I'm turning this saw wave into a modulation signal. And sorry for the glitching, that's either my internet or my graphics card or that. This is Mark, Feeder T. Taylor lives in San Francisco. I'm here in Asheville, North Carolina. So what I'm doing here is it's basically kind of jumbling between these different outputs and creating a unique shape that way. But I could also say, take this. So it's very relatively slowly switching between each one, and you don't hear a. It's cool because you don't hear a pop because they're automatically crossfaded when Audulus switches between two different inputs, and so it avoids that little click that you'd usually hear. If I get this up to an audio rate, though. Can go inside of here and change the maximum to say 10,000. A little aliasing sound there. Can also, if I want to have it be in tune with, so I've got this sequencer going through here to the quantizer, and to value, you can see these different, this is the like volt per octave type standard that we have in Audulus, and that's getting translated into a hertz value here. And if I turn this hertz knob all the way down, that activates this input. You can hear how it comes in sync now. This is the saw wave output here. It'll sound different if I put different outputs here. That's the triangle, the sine. And if I want to change the octave that this is going in, I could say, take this one. Thanks. Thanks, Christian. Let's see. I could have a whole different sequence going here. Controlling this. If anyone has any questions, you can go ahead and ask. I'm just kind of, I didn't have anything planned for today. I figured people might want to ask me how to do something in particular, so I was just kind of playing around with this idea here. A lot of what you don't see in the other videos that I've done before is just like, endless hours of doing this, just trying different things and playing around, attaching different things, just seeing how they sound. VOSIM synthesis. No, I haven't. VO. What does it stand for? So like a link or something you could send in here that other people could check out too. That's to Fedor. Fedor. It's like a woody type of tone. Oh, really? Okay. Can you explain for everyone what it is then? Is that a permission or something I can? Maybe I can. Maybe next time I can. There's a setting or something that I might be able to change so that it'll allow for links. Oh, that's cool. Nice. A lot of people on the forum right now are talking about different types of wave shaping synthesis. And one of the ways, like, this is hard switching between the two oscillators. But you can also do something where, say, I'll just put that aside for a second. I could go down to here, and I go to, what am I looking for? For the Infinite Crossfader. Okay. So this has got some little instructions by it. Go here. And so this K is the knob. Number is the number of crossfade blocks. So there's 2. So I could say I could make a triangle oscillator. That there. And this is the in-out. So I'm going to put the first one here. First input 2 there. And then this chain goes down, and you can just keep creating these, and you would, you know, take that one to that one if there were more. But right now I only have 3, so I'm going to take that one to here, and then that one to here. I can delete these, and then should be able to, there. So now it's on the saw right now. I can morph between the different sounds. Oops, probably aren't hearing it very. This is on the triangle. Audulus too is it's really easy to copy and paste a whole. So like I want to add some stereo width to this patch. What I could do is I could just copy all of this stuff right here, copy and paste, and then I'll take the inverse. Let's see, yeah, the inverse here. So it's getting faded between in a different direction, and then I'll attach this to. Oh, yeah, that's probably my computer's glitching a little bit. It's a little more depth than just this. So that's just this one. This is that one. And you can tell if you put them right next to each other. So they're going in opposite directions. Do they stay in phase? No. Well, so when you create, when I copy and paste something like that, these are already kind of running, and then they'll, when I paste them, this new one will start as soon as it's pasted. So if you wanted to, you know, sync them all together to make sure they're in phase, you could just go, bam. And you'll hear the tone will probably change when I press this trigger. So now they're all in phase. And also, they would return to being in phase if I quit and started up the patch again. It just has to do with when it sees it as being created. So I've got these, this is one of my favorite effects, the Clockable Tuned Delay line. So if I've got this clock divider here, and I've got them being clocked, so they're staying in sync, and then I have this, you know, function here, the tune on and off. I can actually separate them a little bit. Yeah, so when this is on, this turns this into basically a car plus strong oscillator, especially when the regeneration is turned up all the way. And when this gets turned on, it's basically the same as having this button pressed all the time. You can hear it's kind of tracking along with the oscillator here. Then I can turn that on and off, and you get these kind of delay effects in between that. So this is changing, so this is high pass filters on right now.
Here's another fun sequencing technique. So I've got the first note sequencer. This is creating the notes that are going into here, and then this is translating this 0 to 1 range. So I'll go to here. So turn this down a little bit. So this is 0 across the middle. This is 1, -1, and this is taking this and multiplying it by about 2, and then adding these numbers here. So this is negative and this is positive on the other one on the side of the knob. And you can take a sequencer here and sequence this parameter to translate the whole sequence up and down. So if I go here, I'm going to need a level node to bring this back down. So you see this, if it's just this, just the same thing over and over again. But this is the more, random melody kind of thing, or more evolving melody. And this is something you can do on. I learned this technique from. It's escaping me now, but someone who's does a bunch of modular stuff. You can do this with different, offset module voltages. So you can take like off of a sequencer, you put that into a offset module, and then if you can CV the offset and then go into the quantizer, then you can create this type of technique on your Eurorack module. Oops. Bring the width a little closer together and go to modules mixer. Which one did I call that? Yeah, start mixer. This is user reverb that's really good that I'm going to add in here. I think it's called. It's a whole collection of them.
can we find all these modules? These right here or they're not, these ones, whoops, are user patches, and I just kind of have them on my computer, and so when I go to search for them, I just go up to the little search bar up here, and you know, eventually they're going to get added in, but they all have to be kind of standardized, like these modules. You see how they kind of all look like each other, and you know, it's just a long process, whatever. Those are another two that haven't been added in yet. But say like, you know, the oscillator, you know, modules, oscillator, LFO here. I'm thinking about, you know, different ways to make this a little more navigable. We are eventually going to have this kind of text search function where, you know, you, I don't know, double click on the background or right click on the background and search, and you can just start typing, and it will, you know, narrow the searches as you're typing, just kind of like Google does with the autocomplete. So I could start typing in L, and then every module that starts with L would start popping up, and then F, and then that would probably limit to all just the LFOs. But for right now, you know, there's something. There's a reason why I have this little favorites folder down here, because these are the ones that I use the most often, so I don't have to go menu diving. And to make one of these folders, you have to do this on a computer. You go up to here, oops, and then open modules folder, and then you can create a folder in this directory here, and you can add whatever you want here. So like here's the ES8. I got these two here, and then favorites. That's all these. Oh, scale quantizer tutorial. There wasn't like a tutorial per se that I did on it, Jakob or Jacob, but was there a specific question you had about it? You can, what's going on here is I got this clock, and then it's getting divided down. You got different clock signals going. You know, here's a probability module here that, you know, sometimes it'll do this clock signal or that clock signal, and going through here is the sequencer. This is a translator module, and it's translating this 0 to 1 M signal into this O signal, which is kind of the volt per octave standard in Audulus. And the way it works in Audulus is that instead of being 0 to 10, it's the reference pitch is 0, and 1 is an octave above the reference pitch, and -1 is an octave below. 2 is 2 octaves above, -2 is 2 octaves below. And the reason for that is because you can go all the way negative into like LFO ranges and still be in tune basically with the scale that you're playing in. Yeah. Cool. Anyone have any particular questions? You know, I just went from this kind of, you know, hyper, showed you how you can go from this hyper intense kind of techno-y thing. When you just slow the clock down and change the envelope settings, you can kind of create a ambient evolving soundscape. Reverb helps too. You know, I gotta check this. I just installed Windows on my computer, so I can answer questions like these. I haven't used the Windows version very much myself. If there's not, then there will be, or there should be at some point. So, but it is a super convenient way to be able to organize your favorite stuff. If you want to do that on iOS, what you have to do is you can go into a module, and in the module browser, so you have like these modules that you've added there, you click on or tap on the name, and then this metadata will pop up, and then you can add as one of the tags to the module like favorites or starred or something. I would suggest putting it as like a symbol or something that would come before alphanumerically in the whole tags list. So like every time you want to go to your favorites, you know, you go to the pound symbol that's on the corner, rather than having to scroll over to F for favorites. And you know, of course, that's again, there'll be faster ways to do this in the future. Taylor and I, we've been talking about how to redesign the module browser on iOS, and there's a thread on the forum right now where we're talking about different ways that could take shape. And you can go there and participate, and you know, voice your opinion about what you think would be best. But right now we're thinking, like, you know, imagine this is the iPad screen. You know how, like, when you're in the settings for some kind of I don't know, like if you're going to the utilities or the settings for the iPhone, there's this white menu, and then you have all these little options. You'd be able to click through really quickly from one option to, you know, so you'd have like the whole, it'd be more like this, you know, where you have the menus you can drill down, but instead of them expanding like this list, you would press on this, and then it would be this list, and you press on this, and be that list. Excuse me. Yeah. So what I just did there was I grabbed one of these, you know, series, copied and pasted, put it up here, and then have it. Now I'm sending this different pitch information to the square oscillators. Double tap. Oh, that's not a bad idea. Huh. Yeah, there definitely needs to be a faster undo redo. I mean, it's so nice to be able to, like on the computer. It's actually why. That's why I prefer working on the computer, is because it's a lot faster to work with. I like working, you know, with the iPad or iPhone for performance stuff, or when I have it like hooked up to my modular and just want to mostly play with the modular. But you're right, like that's the kind of thing, like if you think about it and you have some good ideas, like come to the forum and put them on there, and so, you know, we can have them to discuss and, you know, think of better ways to make working on the iPad faster. I would love it. I would so love it if it was as fast to work on the iOS system as it is on the computer, because I would use it a lot more. I'd probably just, you know, sit in my bed and make patches all day like that, instead of sitting at my desk. But, you know, just being able to really quickly step back and forwards through things just like that is, yeah, definitely makes it a lot faster. Change these are, I made these with a knob so that you could apply an LFO to them. You know, let me see, I'll just grab another one here. And you'll see how that affects the pitch. And so this part of the knob is on, and that part of the knob is off. You hear how you can add these random variations just by turning the quantizer steps on and off. It's a pretty nice, you know, evolving ambient thing we got. If you ever want to control two things at the same time, you can just take a knob like that. Thanks, Jason. And with all these live streams, you know, if I end up making something like this, I'll always post the patch in the forum afterwards, so you'll be able to download this stuff and play with it yourself. I'd say so. I kind of like this stereo type oscillator thing that I have going on. And so I'm gonna do so one of the nice functions is I can group this together into a module. And let me see, I'm gonna go here to here. Then right click and then go group. Oh, of course. Sorry, guys. Like I said, I don't have the fastest, best computer, and I'm also running the beta of Audulus whenever I'm doing these kind of things, so that might happen from time to time. Well, let's see if this happened. We'll try it again. Group. Yes. Okay. There we go. What is it in here? Currently not. Yes. Cool. Oh yeah, thanks, Steven. That's I think a lot of it has to do with this reverb. Honestly, it's the, you know, just huge. Like, I mean, you can increase the width here, decrease it, and then this kind of reverses it. So I just added all of this stuff together, and you see there's a lot of redundant inputs here. And that's because this was left outside here, and those going to all of the different shapes of different oscillators. But what I can do is instead take these. Let me see. Okay. Different oscillator. That one's going to that one because we have the different sequence that's going for the square one, and then the amplitude. This is basically the same as all of these ones coming in here. It's just, that's how it automatically created them. And then we only really need one shape. I can delete all of these extra ones. We have those inputs there. And then these are the two outputs, so we can say call this something. What do we call it? I don't know. Usually, I'm just gonna look at the ceiling and think about stuff for a while. I don't know. Morphing oscillator. Morphing stereo oscillator. And you see, if we go unexposed, that shows you that this text is not on the UI of the subpatch above it, and this could be like patch commentary. But I could go expose, and then that turns into that font. You want to make sure, you see how this box is over here? If you don't extend it out enough, then sometimes it'll bounce around when you're zooming in and out of the module. Ah, there we go, another. Another glitch there. Sorry about that. Oh, whoops, I forgot. reverse modulation there, so 2. So actually, I want to do the shape. I want to turn that into a knob. That there, and now I'm going to replace this with all the shapes. You know what? I forgot. I want to turn this into the O signal, so I need to put this on the inside. Reload. Come on. Okay, take that off. This one. Yeah, it's gonna happen again because I need to. There we go. This one's gonna go. All right, that should be all good now. So this is like the amplitude of the synthesizer, or the oscillators there. It's basically like a built-in VCA between here and the oscillators. And what I usually do is I'll go and create a light. There. The forum does accept links. Oh, yeah. So like after this is done, I'll post it up on the forum, and it'll have its own topic up there, and discussion around this particular live stream. I'll probably make a whole live stream section of the forum. So hey Robert, how you doing? There's Robert and Michael. So this is E, it's short for envelope, and I'm going to put it over this. So this is the envelope coming there. And that light, I didn't expose it, so I have to go back here. Oh yeah, I guess this isn't, this is sleepy time music for you. I'm going to put it behind this, and so it's just a way you can tell what the signal strength is going in there. And E is it's another signal, another standardized signal in this module library, where this is 0 to 1,
And the M signal, the modulation signal, is also 0 to 1, but the E is just specifically for envelopes. And let's see. So now I'm going to go to this. And I usually put the pitch on top of the whole module is going to end up being right here, but I usually put the pitch on top of the envelope. So, you know, for longest time, I have done this really minimal thing, and the idea behind doing labeling everything really minimally is that it would be more understandable to people who don't speak English and just have, you know, different languages. You know, you can kind of tell and get a hold of it. I'm not liking that idea so far, just because a lot of people complained about the kind of obtuseness of it. Not to mention, I mean, just all the documentation needs to be updated. But I want to do something more like this, where I'm going to actually make use. So it's going to label the signals here, but also label them redundantly like that. So I can do like pitch 1. Or actually, square pitch. And recently, people have made these really cool, you know, SVG, scalable vector graphics, I think they're called. And you can make little symbols that you load into Audulus that you can have. So like you can have the wave shapes in there too. I'll add that eventually, but saw, triangle, pitch. And I'm still going to add the O in there. Edit. Oops. Expose. That'll put it in a different spot. And I usually do, so if I, there. Just go ahead and move this envelope. I'll put this. Shape. So you can see how it's coming together and starting to look like an actual module now. E is envelope and O is what? Pitch, yes. Yeah. But it's not just hertz, it's the sort of volt per octave standard that Audulus has, but it's again where it's the reference pitch is 0 and then 1 is 1 octave above the reference pitch, -1 is 1 octave below. And if you want to change the reference pitch, you can go into the quantizer and, oh wait, sorry, not into the quantizer. You'd have to go into this thing, the O to hertz. If you want to change that reference pitch, you can just change it here, so the referencers. So D sharp is turned on and a value near D sharp is triggered, and D sharp will be played. Oh, the next note that's turned on will be played? Yeah. It's basically, like, say, so, to illustrate this, do this. I think this will work, right? Okay, so you can see that, you know, I got this knob coming in. 0 starts at A, because A is the reference pitch. And if I go all the way up to 1, then that's A again. So it's going around the pitch up. But say if I turn off D, then it will skip over to E there. And depending on, so if I have this turned on,
you know, when I turn this off, where it's going to go, there or there. Turn it on, if I have it up a little bit, then it'll go over to here. See what I mean? So there's a little wiggle room there, but if I turn this on, yeah. So that's how you get this kind of, you know, when it picks a note here, it'll go in between the two. These are audio signals, so whenever instead of going into the menu and going to text, I often just take whatever text is nearest and then copy and paste it and pull it over there. I do that for pretty much any kind of node. Oh, I forgot, I'm going to put the audio light on here. Favorites. There. Okay. See how that light ended up on top of the A? I want the A on top. Well, I can go in and I can highlight the A and then command cut and then paste, and then now that will be on top right there. Same thing here, whoops. There we go. Put that in the wrong order. Oh, whoops. Expose. See, that one was, when it got exposed, it was in, or when it got copied and pasted, it got copied and pasted at the same place. If you want it to like return to some place where you can go grab it, you unexpose it and then expose it again. And then I do the same thing here, unexpose, expose. And then this is the, right here, this is like the 0, origin point. So each element here has a coordinate that is hidden in the patch details, in the kind of the overall structure of how this is all put together. So you can imagine this is like an axis here, and this is the 0 point. And so the coordinates down here would be like negative something, and then this would be positive something, negative something over here. So this is the negative y-axis. And you don't really need to know what the coordinates of things are in particular. You just need to, you know, understand that that's how it works. Where like, if you copy and paste something in from another file, it will have that file's coordinates in it. So like if it's way over in some place, you might end up having to zoom out really far to find it. The quickest way to do that though is you just double click on the background, or if you're on iOS, you do show all, and it will zoom out to fit, or zoom to fit the little element that might like be like way over here or something. So negative. Oh. Let's see. I don't know, I haven't really figured out the whole look of this new thing with everything labeled, so we'll just leave it like this, I guess. And you know, it's kind of got the one control in there. There's the 2 pitches, the envelope. Oh, I forgot to label it modulation. Oh, actually, we just want to do this. We could have one of these, and got a modules, utility, translation, and then we want the DC inverter, because I want to take this modulation signal and invert it. And I still need to fix this. That's one of those things in the library. So now we have the one modulation signal coming in there, and that's being inverted between the two. So you place all the components in the lower hand. Oh yeah. Oh god, that was so bad. Okay. Oh, and then I'm going to well, it's not the shape, it's the morph. And I'm going to put another one of these up here. And get the A to M. So there we go. Lock UI, and then now it's a little module by itself. Stick this in there. You know what? Maybe morph should be its own control. These are things that I kind of... yeah, it probably should be. Just like shape. So, all you do is go there, check that out. There. All the knobs, when you create them, if I go to, you know, knob, by default, they'll be 0 to 1. So that's 0.5, it's in the middle, 0 to 1. And you can go in here and set, you know, the maximum, and it will conform to that. But I generally don't do that because it's just as easy to go inside and say multiply to 1,000, and you get the same kind of sweep with that knob. But the advantage is when you pop out to the panel, you can connect any of these like modulation signals directly to that knob, and it will modulate over that whole area. So, do some morph. And then sometimes, you know, when you're creating a bunch of knobs, I found all these little tricks about how to distinguish between the knobs, because usually I like to, instead of labeling them directly like this, and where it goes underneath, I like to put them on the inside. And so one trick is you can, you know, label each and every knob. So if you're making a sequencer and you have a bunch of knobs like this, and they're, you know, when you copy and paste them, they're all going to be stuck on top of each other like this. One thing you can do is you can go and name each of them like 2, 3, 4, etc. Or what I usually do is I go like this, and then boom, boom. So I know, you know, 1 to that, and then all the way up. And then that's pretty easy to distinguish between each of them. So, but right now, I already put the morph in there. The things that are older are going to be below the things that are newer. Down here to shape. The morph inside there. I don't like the way the H was cut off. Morph, I don't know. And delete that. And then I think this is the one that was attached to morph. Oh, and you see how the shape is above the knob here, and it's, or above the modulation signal there, and it's below here. That means that the text is older than the knob itself. So if I go into the text and I cut and paste it, it'll be back on top again, like that. One fractive. It's one of the better ideas. Well, actually, the vias, they weren't my idea. I think it was might have been JD Raoul, or someone. Someone else had the idea, and I was just the one who, you know, eventually included them in there. But yeah, they are. I mean, they're super useful for, like, say this, you know, here, to keep. This is inside of the delay, and especially when you're doing backwards signals like this, like the way that the delay line's coming back around. Yeah. JD hasn't been on the forum that much lately. I mean, but he was huge in the beginning. beginning. Just a lot of the elemental ideas in Audulus were created by him. The whole idea of having a standardized signal flow, having the different, gates, modulation, envelope, that started with him, and having, ideas about translating the knob from the inside. Somewhere there back in the forum history. But say, you see, like, I created this module and then I forgot to, go back and with the regen, wherever that is, it's like down here. It's cut and paste and then it's back on top. So, does anyone have any particular questions? I could just make something else. Play around with this thing a little more. Oh yeah, I know. If you go look at it, it's got some face drawn with Audulus elements. Yes, Robert, I am. I mean, I'm not familiar in that. I don't know a whole lot about it, but I know it exists, and I checked it out a bunch. I saw there's a bunch of cool. I haven't had time to drop back in on the topic that you guys have gone into with the wave shape VCO, which I guess maybe I always thought linear meant it was linearized at the pitch, but I haven't had time. But like, it makes sense that I got it wrong or something. But that's the way that thing works. Wave combination modes. Yeah. See, I've been. I really wish on the oscillator that there was also a phase control, because it's kind of difficult to, I was thinking about all sorts of crazy ways to adjust the phase where, like, you would time the hertz, and then, like, basically you derive, like, one wave period, and then within that wave period you could trigger the sync input to offset the phase. But then you wouldn't be able to do really smooth phase sweeps, like, in and out. So, that would be something I'd like to see on the new oscillator node. Another thing I'd like to see is also like a noise waveform on here. One thing, I guess I'll go ahead and create it, just because I've been meaning to make one of these, but I'm going to make another sample and hold that has some more functions on it, so... yeah, the phaser does come close, but the only problem is it's not anti-aliased like the built-in oscillator, the audio oscillator is. Modular coming through. So I'm gonna create another module. Yeah, true. Yeah. Could you anti-alias downstream? I've talked to Taylor about this, and like if there's some kind of anti-alias node, and he says it's not that simple. It's not like you can just take an oscillator and go boom, like through an anti-aliaser and then out. Maybe that's something you can like start a topic on the forum about, and maybe Taylor can chime in. I'm not exactly sure why that's not possible. It seems like you basically just have a band limiter filter kind of thing going on, but yeah, I mean it will be something in the future that would be really cool to be able to anti-alias oscillators. Also, you know, just having the variable sample rate would be great too. So I got the clock coming in here. So here's the sample and hold going. And what did is there something I wanted to do with the new sample and hold? What was it? I think it was, yeah, I know what it was. So take one of these modules and put it on the inside to make it easier to scale it up. So the chord filter change its frequency as soon as I touch the frequency knob. Oh, maybe you're using the one that I made or something, but there's the one that I made is, it's in one of the example patches, is not finished yet, and it's got this auto normalization thing going on that I haven't quite figured out yet. Shrug emoji. Oh, work in progress. Okay. So I wanted to make one of these so I could do something like this really easily. Add, oops, lock the UI there. Actually, it would be good to put a slew limiter in here. I think I need to... add modulation. Because the slew will kind of make it wiggle and bounce down below 0. You don't want that. Below or above 0 or 1. So this expression will keep the output of this in between 0 and 1. That would be good. See how the slew is kind of smoothing all that out. And this just is, it sounds better on the filter when there's a little bit, at least a little bit of slew. Organic? Huh. Oh yeah, this one goes between, it has two modes, and it's really nice for pitch, where one's very linear up and down, and then the LPF will, I'm forgetting what direction it goes, but it takes it's easier to go up and then slower to go down or something. It's got like kind of two curves on it. And then this mode is where it will take, the further apart the values are, the longer it will take to reach. And this is actually how a normal like analog slew limiter works, I think. But yes, it will be. Milk bath. That sounds nice. Not only will there be a stream that's posted to the channel, but also there's going to be a topic on the forum for this particular stream, and then people can talk about the stuff discussed in the stream there as well. And then also the patch will be posted in the forum too, so like whatever you see that I'm working on right now will be there for you to open up and play with. Is this loud? The way that I have the monitoring set up is that I'm actually monitoring the synthesizer here through Ableton, just because of the confusing routing that has to happen here. Is the synth loud enough at this level right here, or is it better at like this level? Oh, okay, so I'm peeking there. Okay, cool. Thanks, Robert. Gotta redo these LFOs. I did all this stuff and then I haven't gone back and revised it, but I don't like how it's hard to tell exactly which one is pulled out of here, but I think it's this one, so. So now the two filters that are kind of in the opposite direction, they're getting swept back and forth, high pass and low pass, so it'll add some more stereo action to it. So let's see what this does. Sorry. Limit this. This way it'll only go up to like right there. In the top right, I don't know, they're bigger. Sometimes I forget about the constant node, to be honest. But what Robert's talking about is, so you see how these knob nodes here, and you know you can go into and rename them. And if you put them inside of a patch like this, they'll be automatically exposed to the upper layer of that patch. But if I put in a constant node right here, I can use this as like a little trim pot basically on the inside, and nothing gets exposed there. And you actually can't expose it because there's the knob. But it's nice for, you know, a little trim pot action where you know, you just want to adjust something and then pop back out and pop back in. Or, you know, in this example, you could put a constant node here and do this kind of stuff instead of having to, you know, create a node and then delete it or something. So I put another sample and hold to modulate the speed of this sample and hold. The result that's added with the sample and hold there. Well, I don't want to overwork this because I want it to be a fun patch that people can come in and, you know, play with and everything, but I'm not in a rush to leave either. I could still, you know, stay and talk some more, but is there maybe something that you guys
want me to show you, or the tutorial videos? Yes, definitely. Right now I'm this is Steven down here. Right now the priority is getting the updated documentation out, so I've just been working on that instead of trying to make more, you know, well-produced tutorial videos. But this is the kind of balance, the you know, whatever. I have time to do this. This is easy. I can just, you know, I'm already making patches, and it's easy to just live stream it and talk to people as I'm doing it. And so this can act as sort of like a tutorial. I mean, it's obviously, you know, a little more rambling than the focus tutorials will be. 16-step sequencer? Oh, we can do that right now. Okay, so I have this 8-step sequencer. I'll just have this one going on in the background, just as like some soundscape, but we're going to open up a new patch. Whoops, I need to maximize that. So there's an 8-step sequencer tutorial, and as the tutorial happens, I show you how to make this. And you know, what it's doing here is it's clock. The clock signal comes in here, and then there's this count up module here. The count up module is counting up 1, 2, 3, 4, 5, 6, 7, 0. It starts at 0 because this mux 0 is input 1, 7 is input 8. Yeah, totally. I mean, it's one of those things where I plug at it a little bit each day, but you know, I just got to get it out. I swear, by the end of this month it will be done, at least the node documentation, and then that'll be like a big kind of multimedia synthesis textbook that you guys can check out. And I'm sure there'll be lots of questions and stuff that arise out of that too that'll guide the rest of it. The whole documentation about the modules, that'll come, the individual modules, like if you pop out and, you know, like a documentation about this, but eventually I want them all to look like this on the inside. This was kind of like I did this one as a example or something, trying to figure out what I wanted to do for each module. Okay, I'll jump back to the sample and hold. I did kind of breeze through that real quick. We'll come back to this. So the sample and hold node here, every time it's triggered with a clock, it's the rising edge of this. Every rising edge of the clock that comes in will sample a new value that's coming in here. So if I, for example, let me see, right here, clock. This would be a little easier to visualize. Put a sine wave going through here. So the faster this clock goes, the more it looks like an actual sine wave, because it's, you know, sampling it faster. And if I slow the clock down, you start to see these little hard edges and things. And this is literally, it's downsampling. So you could use this as an effect where you could pass audio through here, and it would actually, we'll just show you what it sounds like. So where'd that go? It's here, here. It's gonna sound really distorted, but see here. So it's only gonna, right now it's running at 100 hertz. I'll turn this down, go to 1000. You can start to hear more and more of it, but you're gonna need to
this is, you know, going a little deeper into it. It's not bit reduction. It's sample rate reduction, but we'll get to bit reduction in a second, and I'll show you the difference. It looks like bit reduction, but it doesn't have quite the same effect. So if this is only able to represent frequencies 500 hertz and below because of the Nyquist sampling theorem, where you need the sampling rate to be twice that of the maximum frequency that's represented in your sound source. So as we go up, you'll hear, actually what I'll do is I'll have a knob here and multiply, whoops, multiply by 20,000. We'll go up to here. So you can hear how it's raising up. You're getting more and more resolution out of it. That kind of whistling you're hearing is the aliasing. Love the Audulus UI and UX. User experience, I guess. Synth player, music producer who is fresh out of coding bootcamp and would like to explore this field. Any suggestions? Yes. The way I really got myself started was wait, so it samples the triggered frequency. Ooh, sorry, I'm gonna come back to your question, Milkbath. No, I'll jump back in. So, this is just audio as it's coming in. It's not a frequency, and it's just the wave going up and down, back and forth. And so, like, up at its maximum is +1, and then at its minimum it's -1. You got all these like little decimal places in between, and so the faster this is being triggered, the more samples it's capturing. It's like more little snapshots. And when you have them fast enough, like right here it's going at 8,000. If I turn this up, it's taking more snapshots per moment. And then it can represent more frequencies. Yes, true. But so if I turn this down, capturing less and less of the audio as it's going by. So if you're, yeah, okay, you got it. So if you're only sampling at this rate, you're not going to be able to catch the high frequency fluctuations in between each one. So, but we can actually show you the difference between. It doesn't necessarily sound all that different, but bitrate reduction is different. So this is lowering the sample rate of the wave as it's going by, like this, you know, from one point to the other. Bitrate is making the wave snap to different volume levels. So just put this back in. Okay, so this is sample rate reduction. Right? And the difference between sample rate reduction and bit rate reduction is that bit rate reduction will look like the same thing every single time. It's not going to, because right now basically the clock and the LFO are out of phase with one another. Actually, if I go like this, and trigger. See, now the clock and the LFO are exactly in phase with each other, and so it's only being sampled at one, you know, point at the highest point there, and so there's nothing coming out of it. But say if I multiply the hertz here by 2, whoops, not hertz, 82 by 2, or let's do 3. I don't know. I don't know what I'm trying to say here, but you get the sample, yeah, this little staircase effect. But if I want to do it with bitrate reduction, go here too. Off the top of my head, I'm actually blanking on how to do this, but there is luckily, in the effect, bitcrush. Yeah, okay, so you can use this floor function. So take the signal that's coming in and you multiply it by a factor, and then you divide it by that factor. So if I have this signal's 1, this is 10, or let's see, that. So it will cut off right there into the tenths place. If I have 100, it's going to cut off to the hundredths place. If I have 1,000, it's going to cut off to the thousandths place. So this is what it's doing is it's truncating the values that are coming in here. So it's quantizing the little steps in amplitude that you can make, and it sounds different than sample and hold. So actually this will be easier to see if we go faster. See how it looks? It looks the same way every time, whereas this is kind of all over the place like that. That's going to sound different out here too. Where did that little buddy go? There it is. That's another, if you're having trouble finding something, and as long as you have things that are kind of neatly laid out like this, you can select all, and then I could immediately tell like this thing is out of place because it's these little boxes kind of laid on top of each other. So start with the wet. So it sounds similar, but it's not the same effect entirely. So if we go back to the sample and hold, now that we understand the difference between sample rate reduction and bit rate reduction, go over here. And what's going on in this is that this sample and hold module is being clocked. We've got this random node here. And this random node is just creating random integers between 0 and 1. And it looks like two different lines being drawn, but it's actually just too fast for the this waveform meter to draw, so it just draws this, like, it averages it on the top and the bottom. If we go to value node, you can see it's just kind of all these random values. But so these are, every time it gets clocked, it'll sample a new number coming out of here. And then this number is going through this module, and this is scaling it between, so this is the ultimate range that it'll have, and then this would adjust the floor, so you have the bottom of where the signal can reach. So it's at 0 now, and then I can raise it up.
And in general, you know, in Audulus, meter nodes and value nodes are your friend. If you, or in waveform nodes, if you want to see a signal changing over time, you want a waveform meter. If you want to see a precise value at any given point, then you want a value node. You know, when you're measuring audio, it's not very useful to have this coming out because it's you know, changing all the time. It doesn't really give you much information, but this does. You know, meters being these things. You know, they can show you, like, say, the instantaneous you know, aspect on a scale. So like this is 0 and this is 1 up here, and you could put a scale next to it to, you know, show where something's at. And you know, so then it's going through here. The slew module is to smooth out the transitions between the different numbers, because especially when it's applied to a filter, or say like even volume or something, you get these little clicks if it's not smoothed out, and then that is again to just constrain the movement between 0 and 1. Yeah, I know. So, you know, is it Jakob or Jacob? But you know, I started out as an Audulus user myself, and I actually had it for iPhone, and it's, you know, I was just stunned by how deep it was just for the iPhone. This is back in like Audulus 2 days, and you know, I just so happened to be one of the users who got good at using it the fastest, and then you know, used it a lot and talked to Taylor a lot, and eventually just convinced him to, you know, hire me. And then out of doing some patches for Audulus 3, I came up with the idea for the module library of having all these, you know, modules, because basically before it was all just all of the nodes, and you had to build everything from scratch every time. So that was kind of like my contribution to Audulus, was bringing the modules in. But basically, anything that I've ever done in Audulus, there's been very little that I've run into a wall with, and it usually has to do with sampling or MIDI out or something, features that aren't added yet but will be added eventually. And you know, but for a lot of parts you can add your own things, like say, yeah, yes and no. Honestly, you know, the math thing, I thought, yeah, you need a lot of math at first, but no, you don't really. What you need to do is you need to go to the Sound on Sound synth secrets. Yeah, I know, totally. It's the Sound on Sound synth secrets. Look that up, and you can actually put in like .pdf along with it, and people have made these PDF versions of it you can download all at once. Sound on Sound is a UK-based magazine. They're great, you know, audio engineering magazine, and they had this whole series for years that was on synthesis, and a lot of the topics that they discuss in there, they have these block diagrams, and they show you how, you know, from oscillator to VCA, VCF, that basically translates one-to-one with what's happening in Audulus. Excuse me. And you can take those diagrams and then apply them into Audulus and recreate them there. So if we go into the delay, for example, so here's the delay node, right? And by itself, it's a very it's a digital delay. It reproduces exactly the audio in and audio out. But if you look at the block diagram for a analog delay, what an analog delay has is a low-pass filter in the feedback loop, and that's because there's artifacts that get built up over every single repetition of the audio coming around through the delay loop, and it builds up this aliasing sound that's not very pleasant, and so you have this low-pass filter in the feedback loop. And so if you know that from the block diagrams that you're seeing
represented, then you can just add a low-pass filter in the feedback loop like this. And, you know, there's some other things that are, you know, like that's the audio coming in, that's the dry audio, and then this is the wet audio path, so there's the feedback loop here. This is to prevent the feedback from increasing too much. It kind of squishes the audio as it comes around every time, and it gets this kind of nice soft distortion going on. And that's how I can have the feedback right here, the regeneration, cranked all the way up, and it's not just spiraling out of control. And then, you know, here, this switches back and forth between the high pass and low pass filters, so you can get a different sound out of it. And then that just mixes back in the dry audio and the wet audio signal. So, you know, there's no math here really at all. I mean, there's this, but I mean, I don't quite understand how the hypertangent works. I could look it up, but you know, and I've been meaning to, but I just know that that's like the soft clipping expression, and you can put it in there, you know, and all this stuff here. So you know, here's some quote-unquote math, but all this is doing is this is changing the way that the knob responds here to the modulation. So the modulation, you know, you have an LFO that's coming in here, and this is making this 0 to 1 knob have a really steep curve to it, so that for a long time it's only just like a little tiny bit. Like if you go mapper, so you can also do it with a mapper like this and have this connected. But basically, what this series of squaring is doing, because it's multiplying it by itself. So this is like squared, squared, squared. This will make this response go like boom, whoop, up like that. And actually, I can just show you how that looks like this. And this is like pretend moving the knob. Oh, I forgot. Here, this is one. You can't add a modulation signal to a knob within the patch. So this is one case where a constant node does come in handy. Oops. So that's the response of the knob. So see, for this entire portion right there, it's almost no increase at all. And that allows you to dial in a really subtle modulation effect in between here and here. And you can tell it like that the way that those numbers are moving a little bit, that's wiggling the Type knob, even though you can't quite see it wiggle here, but it's wiggling it enough to give it a kind of chorusy, phasey sound effect. Linear to exponential, and then there's, you know, you can also make something logarithmic. It's whenever I want to make something logarithmic, I usually just use the that mapper node thing. You can actually stack these mapper nodes too. You can do the same thing. So if I have one like that, and you can like that, and then this will make it very logarithmic with the input coming in here and coming out here. So, you know, that's, you know, quote unquote math. You know, here's some addition. There's some math there. You'll use these things more, these logical expressions, or like kind of computer science stuff, where it's saying clamp, you know, just in other words, make this signal, and signal whenever you create a you know, you can create variables by typing words and letters in there. That creates an input. So clamp this signal and make it stay between 0 and 1. That's it. Yeah, that too. So, you know, here's another one. When this signal that's coming off of here is exactly equal to 1.5, then turn this light on, which means it's a triplet. If it's equal to 1/3, turn this on, and it means it's a dotted. I think I might have had those back reversed or something. I'm looking closely at it. Anyway, it's a work in progress, guys. So ultimately, no, there's not a whole lot of math going on anywhere. Here's some math that, like, well, this is sort of like logical stuff, but you know, this is a little more complicated. But basically this is a kind of sieve for the notes, so they get kind of shook out and then end up as a, you know, particular value here. You know, here's the flip-flops. This is the inside the shift register. And each of these flip-flops is just a little sample and hold, where every time it gets straight, you know, here's the little description. You can read all about it, but, you know, 1 minus flip-flop, that's the math right there. Now, other math comes into play when you're talking about the filters, though. And the filters are more complicated, and you've got some... But ultimately, this is still stuff you can just look up and kind of copy in a sense of you don't need to understand it completely. You just need to know enough about it to be able to reconstruct it in Audulus and see the differences between the what's there in like the textbook and all this stuff like filter resources about doing DSP stuff. This is all like available on the forum. People have posted it there. So, you know, like, I don't understand any of this stuff. I still have to make time for, you know, diving into filter land so I can explain it to people, but, you know, this is, still not all that super complex. It's not like there's calculus or anything going on here. Like, this is just the, you know, if the absolute value of x, the input, is greater than 0.5, make this go high and turn to a trigger. And I don't know what exactly this is doing. I think Robert asked this question in the forum, what this envelope was for, and there's some reason it's there, but, you know, here, 1 divided by, you know, 1 plus 2, it's all very simple math. So it's less about knowing math and really just knowing about synthesis and how to use it. So, you know, like here's the variable envelope. This is something I wanted to create, so it gives you both beginning of cycle and end of cycle triggers. So if I speed this up, whoops, if I turn this down actually, so you'll see these light up. So it's it goes to there, to there, to there, and if it was longer, it would go to the, you know, sustain a little bit and release. That's kind of nice. It's like a little flute. If we go in here, all this is it's just a tricked out envelope module, and we got going in here is the different parameters. So like you got the attack comes in here, and the attack is made exponential, so you can dial it in easier. And then these are all going through this mono to quad, quad to mono just means that all of this stuff is being multiplied by this factor here, which is the maximum time thing. So this way you can change all the attack, decay, and release settings all at once, rather than having to dial them in differently. And so you have like a maximum of 60 seconds here. So if I turn this up, that makes the... You can see how... This is what I mean by that exponential response, where you have this twice squared. If I go up, it's all the way up. If I go down, it's all the way down. But see how long it takes for it to go up there. So like when it's set halfway, it's only at 3 seconds. Then up there, it's at 60 seconds. So these get multiplied by this number. So then they go out here to become the parameters here. But then what I do is I have these settings up here, so like when this timer, it gets triggered by the same gate that's triggering the envelope, when this timer is greater than or equal to the period defined as attack, there, see it keeps on going up, when that is greater than or equal to, then this statement becomes true and outputs a 1. And then you take that 1 and you put it over here, and then that becomes another gate that you send out. And then this here is the end of cycle. So whenever this goes low, see this is inverted. Whenever it goes low, it resets this timer, and then, excuse me, all of the end of cycle gates are just stuck at, excuse me, at 1/10 of a second. So each of these will fire for 1/10 of a second. And same goes, so I take this, the attack timer, when the decay plus the attack time period is greater than or equal to the timer, and the attack, this thing is finished, when it's finished with this this period, then when both of those statements are true, then output that trigger there. Oh, okay. Void transients, cool. So, you know, this is stuff that, I mean, no one taught me how to do this thing here. It took, you know, maybe, I don't know, 2 or 3 hours to figure out exactly how to do each one of those things, to make the module in general. But, you know, once it's done, it's there, and then people can look at this and then, you know, use it to do other stuff and other types of, you know, you can go in and learn about how this is done here and apply it to other modules that you do. So, yeah, I mean, there's really very, very little math involved in Audulus, and the more of the math that is complex is going into either doing filters or sometimes creating oscillators. So if we go in here, you know, here's some of the deeper math, super deep math, is that the phaser goes from 0 to 2 pi, and you know, it just goes in a saw wave. Here. Oops. Go down. So this is 0 and 2 pi, and this is going around the unit circle. And if you take that phaser and divide it by 2 pi, then you get 0 to 1. And then if I have this 0 to 1 value, 1, this is like an old greater than module, but when this signal is greater than 0.5, then this goes high. And then this is the inverted version of that, so that goes low, so you get the inverse of each signal. And then so this is the saw wave here that's just coming out there, and it's inverse. And then, you know, here is, you take the absolute value of the saw minus 0.05. So if I go to, so this is translating this saw wave down, so it's going in between the middle, it's going in between negative 0.5 and 0.5 at the max. And then if I take the absolute value of this, like that, then I get this triangle wave, right? But then it's only going to 0.5, and I want it to go to 1, so I just have to multiply it by 2. So 2 times that. And that's how I make a triangle out of the saw wave. And the way that I figured this out, well, someone else figured it out before me, and then I forgot how to do it, and I couldn't figure out where to find this, so I just went on Wikipedia and then looked up triangle wave. Literally just I wrote in triangle wave, and then this expression is basically there. It's in a different form, but then, you know, here's the more, you know, this is trigonometry involved here. So if we take either the sine or the cosine of phasor, so do the sine, you get a -1 to 1 sine wave, which is, you know, just basic trigonometry. The reason we use cosine here is because the cosine happens to be in phase with all of the other waves that are created there. So you can see that it's 90 degrees out of phase. And then, you know, it's just, that just translates that -1 to 1 into the 0 to 1 range that the modulation signal works in. So, like I said, like that's the most complex math that I've had to personally learn to understand what's going on in Audulus, but otherwise it's, you know, pretty simple. All right, does anyone else? Oh wait, no, I forgot. We're going back to the. So okay, so Robert asked a while ago about the step sequencer and how to expand the number of steps. So in another tutorial I made this sequencer, and it's got these two sections. This one is the lights section, and this is the values. So you get this mux node, and a value of 0 will send this input 1 to this output, or sorry, a value of from 0 to 0.999, etc. will send that value out, and then 1 to 1.999, etc. will send 2 out. So that's the only little confusing thing about the mux node, is just it's difficult to kind of visualize that, but it has to start at 0, because otherwise, if you had nothing plugged in, then 8 would always be the one selected if it had to be 1 here. You can do that easily with the count module. The count module starts at 0 and then counts up, and you can just have it a maximum of, here. So this floor just rounds it down to the, or just basically cuts off all of the decimals. So that's 7 is the maximum step. But it's really, you want to think of this as, if you had this as a display in the front panel, you'd actually go to, select +1, and then you'd expose that there, and you could say this is the maximum step. But I also have the little visual indicator there, so you don't need a number to also tell you that. So what this is doing is that every time this clock gets pulsed, it counts up a number, and the counter is in here. And this is another thing I think J.D. Raoul came up with, and it's basically like basic computer science of like from one line to the next of like you trigger this, and then say the input is 0, and then 0 comes around here, and say this maximum is, we'll just fill this in with 8. If the signal 0 is less than the maximum, and then add 1 to the signal. So then this, if the signal is less than the maximum, that becomes a 1 because it's true that 0 is less than 8. Then that turns into 1 times 0 plus 1, and then that goes over here. And then it gets triggered again, and then this 1 gets sent to the output, and then the output comes back here, and then you have 1. 1 is still less than the maximum of 8, and then you get the 1 plus 1 equals 2, and then so on and so forth, and that's how it counts up. Okay, so if we want to add more steps, it's really, really simple. So I'm going to first change this so it's a maximum of 16. And the way I'm going to do that is I'm going to go over here, let's say 15. Because it's really, we want it to count up to 15, not to 16, because it's 0 is like the quote-unquote first step. And what you're going to see here is that, whoops, the sequencer is just going to repeat. It's just going to go 1 through 8, 1 through 8. We don't want it to do that. We want it to go up to the 16th step. So I'm going to copy all this stuff, paste it, go up here, and then what I'm going to do is I'm going to add a little expression here that says when the step is less than or equal to 7, then, whoops, so when the step is less than or equal to 7, multiply that by the sequence. So the sequence is here, the step is here. So then you see the space in there, that's going to be the space that this one takes up. And that's still steps 1 through 8, and this is steps 9 through 16. So then we take this same one, and then we just go when it's greater than 7. Multiply the sequence. So this goes through here. And see here, now put them on top of each other. See how they line up. But what we want to do is have this strung together so it's all 16 steps together. So what we do is we just have to go to math, add these two together, and now we have a 16-step sequencer. different outputs here. Whoa, whoops. So this is the 16 steps right here. And you can do this, you know, say, well, let's go ahead and make a 32 step sequencer. So I'll copy all of this stuff. Copy paste. Put all that up here. And what we need to do now is this one works okay. We need to actually increase that to 1. So this one can stay the same, but this one needs to have another bounding around it, because it's not just when the step is greater than or equal to 7, it's also when the step is less than or equal to 15. So to string together different conditionals like that, you just multiply them by each other. So step is less than or equal to 15. This one is the model. Delete that. That's the sequence. And then we just need to swap the numbers here. 15 and then what? 24, so 23. And then this last one we can just do step is greater than 23. And then go here to mixer. And this is just basically like a 4-input add node. And then there we have it. We have a 32-step sequencer. Yeah, this is, I think it was JD Raoul who came up with this. It was just so simple when he did it. And then, of course, I'm not going to do it, but you'd have to go out here, and then all of these knobs are, like, stacked underneath this stuff, and you have to sort all this stuff out, and you can just make the sequencer that way. You do the same thing down here with these inputs for the lights. Except what we're going to do is, so this one is the, let me see, yeah, this one's the maximum step light, and then this one is the current step. So if I had another these lights, it would basically be, oh, actually this is what you want to do. You want to make these separate, because then you don't have to have a redundant expression here. But steps greater than 7, and then you do this. You have a multiply node, and then I can use the output of this expression here as the input here. So then these would be the steps 1 through 7, and then I'd go here, edit this one. Again, this is just times the sequence. There, and then I'd use this as the input there to turn on the lights. So now you can see the oh, whoops, that's the wrong, that's the maximum step. So here we go, and then it's going to go up there. Oh, whoops. It's kind of light there. I want to change the max to 16. So, there you go. So, apply that same principle there. Excuse me, I should probably save this one. So the other thing though, in the future, you won't have to do any of this stuff, because this is, it's easy, but it's also kind of a BS way to go about this. What we're going to do in the future, it just makes for all this work that you don't need to do. This node won't just be fixed at 8 inputs. You'll be able to select however many, probably right-click or tap on it, and then select however many inputs you want, and then it'll just go through those inputs like that. And that'll make making sequencers so much easier. So there you go. Sequencer 1 8 steps. That sounds so funky. Okay. So we got the sequencers. We got the sample and hold. Anyone else have any other questions? Yeah, Infinite Lux. Yeah, I mean, speaking, like I've made these so that people can. Where is it? It's under. We definitely need the search, because even I guess I get lost in these menus sometimes, especially when it's something I haven't looked for in a while. It's probably under here. Yeah, switch. So like, here's a 64 mux, and you could just, if you wanted to make a 64-step sequencer, you can just pull this thing up and then do that. I did this in a different way with these other expressions, where when the step input, the step number that's getting counted up equals this select number, then you pass the input to the output. Yeah, true, yeah. So this one uses more CPU than the other one does, so it's not necessarily the best solution in all cases. The knob is so different. Yeah. So does anyone have any other questions? Thanks. My voice is getting a little sore, so I think I'll probably end it here. I'll put this up on the forum and put the patches up there too, and just think about what you want me to talk about next time I do this. I don't know, I might do it in a couple days or something. I might even do one tomorrow, but do it like later in the day, so people who weren't able to join us in the middle of the day here, or at least my middle of the day, can join later. And so just check the forum or social media. I always like post about when this stuff goes up. So anyway, thanks guys, really appreciate it. I'm gonna let this run for a little bit.